Alright, started recording.
Nothing is increasing. Oh, so X is right. Okay. Okay, so this is a mind-blowingly simple fact in calculus which everyone overlooks or doesn't look deeply enough. Okay.
So never use the variable d. Because then you'll be like dt.
Prove that.
Leon. That is the question. Let's see.
Okay. There's a famous question in calculus. E to the x to the least x plus 1 for x more than 0.
That is calculus question.
Yeah,
That's like a physics.
just write this.
Yeah.
And f dash of x. X minus 1 at least 0. And x is at least 0. Now you might say, yeah. Okay. Famously, back in 1700s, Isaac Newton assumed that. Wait, what did Isaac Newton assume? He assumed that if f dash of x is equal to c on AB, then if f dash of Isaac Newton assumed that if f dash of x is 0 on AB, then it's constant on AB.
Yeah, it has to be continuous though. Wait, what about A and B? Endpoints.
Yeah, the endpoints may be an issue.
Oh yeah, you might have to maybe open interval. Yes, Isaac Newton famously assumed this in his physics. Then someone realized that there wasn't actually a proof of this. So actually prove this with the mean value theorem. So the mean value theorem is epic.
Think about calculus is even like stuff like this, you still have to prove.
Yeah, so Isaac Newton assumed this without proof.
They got called out for it.
It's like Isaac Newton lived where the school math tradition
But
started.
it took many years for someone to muster the courage to call him out.
Yes.
Okay.
It wasn't the publication delay.
But then mean value theorem was discovered.
I
Now
probably should watch the stream on the house.
this f dash of c, there exists a c such that f dash of c is equal to f of b minus f of a over b minus a.
Yeah, I think it's really just a mixture of intermediate values.
That there exists a c on AB such that the gradient of AB, the gradient from this to this is equal to f dash of c. So now f dash of c is 0. So f of a is equal to f of b. And you can do this for any. You can replace a and b with any 2 points on the interval.
But
That's why it's constant.
0 on 0 is 0, huh?
Alright, interval. So,
what?
so a and b are here, and then fb minus fa.
That's true.
You don't need to assume the derivative is
So if the derivative
continuous
is
for the main value. Do you?
Oh, okay, good.
no, the derivative doesn't have to always be 0 for the mean value.
Oh no, it could be
I mean continuous.
Yeah.
So for that,
Maybe we do need to.
so f Oh yeah,
We
actually,
can prove it if the derivative
I can prove it right. I can try to prove it right
Wait,
now.
prove what?
Mean value theorem.
Oh, mean
Yeah,
value.
prove mean value theorem. I have it in my uni notes.
Oh, interesting. Okay.
Look at this.
This is
Wait,
so-
wait, Yes. The problem is I'm scared of not getting into uni maths course, not getting the ATAR required. Is my for that.
I'm pretty sure you can get into maths without. You get a 97 ATAR and you get into uni.
But the thing is, my English is gonna drag my ATAR down to lower than 97.
Uh-oh. That doesn't sound good.
That's
Because-
odd though.
Oh wait, what?
Not dragging them that much.
Yeah, because I'm getting like 55% in like school assessment. And I still don't want.
Get a
I
get
still
a
don't
band,
want to care about English. So
get
that's
a
the-
band 5. It should be enough.
Look for the average student in the school and hope that your score is higher than theirs.
No, my score is lower than the average student in my school.
Not the average student in English, the average student overall.
Oh. So what do you mean?
I don't know. Overall score rank. What do I mean by here?
Ah yes.
So you realize the
Bus?
median ATAR in Kings is like 86.
Okay. It's actually this is Mean value theorem is
And they're really proud of it.
Mean value theorem is not that
Oh.
easy, but you can break it up into steps.
Or steps.
Say that. So now
If you miss the steps, then
if f is differentiable.
that n may be a bit too light.
If f is differentiable on AB,
There's a blue one also on the.
if f is differentiable on say AB, and
That means it's also
f of x, and let's say f of c, the max that c is in AB, then f of dash of c has to equal 0.
Oh.
So this is Fermat's theorem.
Fermat's theorem.
Fermat's theorem. Yeah.
Fermat's big theorem. Theorem. Fermat was in calculus. When was he around?
1600s.
Oh well.
How does this work?
That's a claim, right?
Oh, okay.
That's a lemma.
We're just trying to.
Oh,
We're just saying stationary points are. If it's a maximum, then it's a stationary point.
Uh-huh.
That proof is.
Oh, so basically the school math stuff that's given without proof.
Oh. Okay.
Oh, actually, that's a pretty good. That's a useful lemma for school. Hey?
Now,
Pay attention.
h is more than 0. Then. H is more than 0, then f of c plus h less than equal to f of c. So limit is at most 0. Now for h less than 0, f of c plus h is again less than equal to f of c.
What are we assuming about f prime of c? Are we assuming
This
anything
is. I'm not doing anything really.
Wait, is it if and only if the
If this then this.
oh okay, so it's only one bit.
Yeah. So now
Oh, so you're concluding f prime of c is less than equal. That's the first.
now h is now negative, and this is still almost 0. So now it's positive. So the limit is non-positive and non-negative.
Wow.
So Fermat can only come to one conclusion, which is f dash of c is equal to
It's
0.
complex.
It does not exist.
It's complex.
See, so it's actually really easy.
Does not exist. H is greater than 0. So the limit, that's like limit from above.
Yeah.
Take the limit from above.
So the right limit The right limit is less than or equal to 0. The left limit is at least 0.
So max it doesn't mean that. Okay.
Right. So it's negative because the f of c is bigger than or equal to f of anything else.
Yeah.
Yeah.
It's bigger. It's not strictly big. It's bigger.
So that is the proof of Fermat's theorem.
Yeah. The bottom changes the sign. Yeah. Okay. School maths. That's basically.
It's basically like, to find maximum value set f dash was equals 0.
Oh, yeah, and the same theorem works for minimum. So it's
Yeah.
Okay, so now we do
like the opposite side.
we do Rolle's theorem. Roll,
Oh. I actually heard of that.
which is again f a b differentiable.
Like, what's the point of having it?
I also
There.
I forgot, it has to be differential on open a b and continuous on closed a b. Yeah. So I think that's a condition for the previous theorem.
Oh, okay. So like,
now
yeah. So for example, like if you have a function like y equals like sine inverse of x, like it's continuous on closed AB, but only differentiable on open AB.
Yeah. I guess.
If you have.
Wait, is it continuous just so the maximum exists?
Yeah, pretty much.
yes. Okay. So now we use our favorite theorem, which is called the extreme value theorem.
Oh yeah. Proved 3 times.
It's also called the max min theorem according to
Proved
uni.
this 3 times, but I still haven't heard it.
Extreme value theorem. Oh yeah, also hang on.
Not about how many times.
F of A is equal to F of B is equal to 0.
F of A equal to 0.
What?
Oh, that's an extra assumption.
Alright, so that means there exists C such that F dash of C equals 0. Yeah.
That's what you want now. So you're just saying there's this maximum.
There's 3 cases. Case 1, constant on AB. Constant AB is pretty easy.
Then you do some kind of shifting, eh?
F dash any is equal to 0.
So wait, what is the theorem? Like,
if it has the same height at the start and end, then it's gonna have
means if you
a 0 slope at the middle somewhere.
Means if you walk somewhere and then come back, at some point you weren't moving.
So it's a special case of the mean value theorem.
Wait, what if I walk in like a circle on back to?
Real numbers.
Oh, so I'm limited to a straight line. Yeah. So I have to stop somewhere and turn back.
Yeah.
Yeah. There's a special case of the mean value theorem for that.
Now, okay. Now case 1 is constant on AB. Case 2 is hang on.
Oh, so basically it's a limited case of
So case 2 is fx more than 0 for
like
some.
fx more than 0 for some x in open AB. Now a maximum exists by the extreme value theorem.
Yeah.
Now f of c max, where c is on the open into AB, then from Fermat's theorem, f dash of c is 0.
Crazy.
Wait, case 3 is the same. Case 3 is just the complete opposite.
Well, case 1, how does
basically
isn't that what we're trying to
it's not
constant on AB is f dash any is 0. Isn't that what we're trying? Isn't case 1
Case 1 just means it's always 0.
Yeah.
Case 2 means it goes above 0 at some point, and case 3 means it goes below 0 at some point.
Yeah.
And case 2 and 3 could coincide as sometimes. Yeah.
Okay. That makes a lot of sense.
So that means theorem.
It's the first time today that it makes any sense at all.
Oh, come on.
That's just so Rolle's theorem works.
Right, so we're good with that theorem.
Yes.
So now there's going to be some kind of clever shifting, huh?
Oh wait, how do you guess?
Shifty.
because all of these steps are fairly
But an instant B.
So now,
Wait. So you are assuming F is continuous then?
yeah,
Oh, you're assuming.
to be continuous on closed AB.
Oh, that's fine. You're not assuming the derivatives.
no.
Alright, keep going.
What's not?
So now
We wouldn't assume.
finally
that
have
consequence.
the mean value theorem.
Mean value theorem.
So if f differentiable on open AB, continuous on closed AB, closed AB, there exists C in open where
It's basically saying it's F is continuous on the endpoints.
FB minus FA over B minus A.
The pen is slightly light. Is there another pen?
Okay, so we do this. FA and FB. Now it's really easy because we just subtract this line from F. That means G of X equals F of X minus H of X. This is the line.
Why?
Line from
Straight line.
line from here to here.
Straight line. Straight line segment.
Yeah.
Oh, okay.
Now it's
That's
really
H
easy
of it.
because G dash of X is equal to F dash of X minus H dash of X. G dash of X is now, it will look like this. So now G dash of X can have a derivative of 0 for
So are we now proving the mean value theorem?
Yeah.
So now it's a Rolle's theorem thing.
H dash. So now F dash of C is equal to H dash of C. And H dash of C is equal
Yes. So basically, we're taking whatever curve and basically subtracting like a straight line from it and putting it back to the Rolle's theorem.
Yes, that's right. So now we can do what Newton failed.
Prove the mean value theorem. Hey.
Oh, you mean Newton tried to prove the mean value theorem and skip that step?
I mean, I don't know about that, but I just assumed it. Well, he failed because he didn't even try.
Oh. Yes. When you do better than Newton because he didn't try it. It's like when some scrub lord approaches being related to
I heard some pretty funny stories. Like Newton hated this guy for the book.
Oh yeah,
You heard the story?
I think so.
It's like he deliberately waited till the guy died before he published his book. It's pretty hard.
like it's just like some scrub lord at school, some like really disrespectful guy in school. But really just says
Wait, do you want to stop that recording?
does that stop it? No.
Alt P. Wait.